Okay, let's get started. And so today we're going to talk about the first assignment that's due and allow you to ask some questions if you have them. And talk about feasibility studies and actually just talk about assignment number 1 in terms of the lecture as well. So by popular demand, you guys don't want to hear about project management, I hear. So I'm going to skip that lecture. So if you are interested in project management and want me to cover it, send me an email message and say, hey, I really want to cover project management. Otherwise, I'm going to assume you guys are bored with it and don't want it. So today's the subject for today is feasibility studies and assignment number 1. Now, you can't turn this in yet, but you don't have to worry, it's not due yet. No assignment is due until the very last day of the class. The reason why you can't turn it in is because the ITU EMS class entry to upload the assignment is not created yet. So there's no way to physically turn it in. It can't be turned in on bhecker.com. It has to be turned in to the assignments link in the ITU EMS, but it's not ready yet, so long story short, I'll let you know when it's ready and I'll demo how to do it. But in the meantime, it doesn't mean you can't start working on it. So not a bad idea to start thinking about working on assignment number 1. And let me talk about assignment number 1. It's not going to require a feasibility study. We're going to do that in a future assignment. What this one is going to be is you're imagining that you are a freelance software consultant. So you're working in the software business. And you have been asked to develop and market a financial software package that can help small trading companies to manage their cash flow. So it's kind of a business kind of topic, but it really is a software engineering project. And you're given a set of requirements and a description of this cash flow management system, which is that abbreviation CFMS. I'm not going to read you this whole thing. So you can download it, read through the description, but you're given this set of requirements. The customer has come to you, you're the consultant, and says, hey, I need a system built that's going to do this, this, and this. And what you're going to do is read through what the customer wants, and at the very end of the scenario here, you have to answer the following questions. So you're going to put this probably in a Word document. It's not a formal report, but I'd like it typed up rather than handwritten. It's easier to submit that way as well. So put it in a Word document. And you're going to state which software lifecycle model or models, so what choices you have to apply it to the software development of this particular system, and justify the reason of your choice and explain each phase in detail. If you did not take the Software Engineering 1 course, if you did take it, you've heard everything in the world and more that you've ever wanted to hear about software development lifecycle models, and you're sick of it at this point. So I'm not going to repeat any of it for the Software Engineering 2 class. If you have not taken the prerequisite course, the Software Engineering 1, go on the internet and look up Software Development Lifecycle Models, or SDL, what's it, Software Development Lifecycle, SDLC. And if you can't find anything, type in Waterfall Model, which is the most popular model out there. And if you're not familiar with what a Software Development Lifecycle Model is by concept, you should be. So go ahead and educate yourself on it. Learn about the different options. I'm going to talk about a little bit about them today as well, but it's going to be in relationship to the feasibility study and an example project I'm going to give you. So go online, educate yourself on that. If you if you find a book, you'll find maybe like one chapter maybe on it at most. Usually, the books don't usually cover the development lifecycle models that much, but you'll find a ton of information online regarding them. And then you're going to discuss how you would go about ensuring the dependability of this particular software that's being developed. So you can talk about how the plan to make sure that it's dependable, the development ideas that you might have for it. What I want you to do is talk about the model and talk about the phases. Say, I'm going to use a iterative refinement approach, or I'm going to use a waterfall model, and these are the phases that I'm going to go through. You don't have to spend that much time with it. Your entire write-up is 2 to 4 pages double-spaced. So that's like 1 page to 3 pages or so, single-spaced. So figure 2 to 4 pages double-spaced. You can make it 2 pages, that's fine. You're probably going to end up going longer. You can make it more than 4 pages if you need to. You can put in pictures if you want. I don't really care. It doesn't have to be in an APA format or MLA or anything like that, just any type of free-form writing that you want. You could actually even put it together like a proposal if you want, or a feasibility report, but you don't have to. And then evaluate some of the possible risks of this particular software development project. So you're also going to think about the risks that are associated with it and how to minimize them. And one way that you can minimize them is to go through this process of this feasibility study that I'm going to talk about today. So the lecture for today goes along with this particular assignment. And I'll tell you which lecture number that is so you can look it up. You do not need to develop a risk assessment plan. That's what we're going to do in assignment number 2. You're going to develop a risk assessment plan. But we haven't talked about risk assessment yet. Right now we're going to talk about feasibility and attacking or approaching the concept of getting into this particular project. And so basically you're going to write it up, turn it in, and that's pretty much assignment number 1. That was a really fast overview of it, but it's actually kind of simple in theory. And I'll give you some pointers on it as I go through the lecture today. Are there any initial questions on that fast review of assignment number 1? Again, if you haven't taken Software Engineering 1, go online, keyword software development life cycle model. Not project management, life cycle model is what we're looking at in terms of what you need to do for that. Oops. All right, so this is, I believe, lecture 5. Yeah, it is lecture 5. I'm skipping 4, which is project management, and nobody wants to hear it. So we're going to talk about lecture 5. And lecture 5 gets into feasibility studies, which is really the essence of what you're doing with that first assignment. Because the first thing you're going to need to do with any software project is a feasibility study, whether it's a formal report that you're putting together or some initial research and initial idea planning. What you're doing is putting together your concept of what you're going to develop. So the feasibility study is generally the go or no-go decision. In your case, you're not really deciding whether you're going to do this or not, because you're given this cash flow management description, and the consultant says you're going to build this thing. You say, okay. I mean, they're coming to you as the consultant, and they're saying you're going to build this thing. I'm like, okay, I'm going to build it. So don't write, on your 2 to 4 pages, line number 1, one sentence is, I'm sorry, I've done a feasibility study, and we're not going to build the software. Now I want you to assume you're going to build it, for the purposes of the assignment. So the feasibility study is a study made before committing to the project normally. If you've already committed to it, then it's I guess, too late for a feasibility study because you're not going to answer the question of whether you're going to build it or not. You've already said you're going to build it. So that's actually, believe it or not, a critical stage that a lot of people miss. They say, okay, they commit to it, and they haven't even done a feasibility study to even know if it's even possible to actually meet the needs of the client or to even develop it. So the feasibility study leads to a decision, and some of the decisions are go ahead, do not go ahead, or think again. Usually, hopefully, it comes back with a think again because, you want something out of it, right? You just don't want to turn the customer away. I mean, not normally. Can we keep the volume down in the back? Because it's hard for me to yell over you without a microphone. Thank you. So in production type of projects, the feasibility study often leads to a budget request. And when I get done talking about risk assessment, I'm going to talk about budget and budget analysis. That's another topic that's coming up. And so the budget request is basically something that's going to come out, hopefully, because how do you know how much money it's going to cost you? How do you know what resources you're going to need? How many hours it's going to take you? If you're doing this professionally, you're not going to guess, because if you guess, you're either going to over or underestimate. Nobody actually guesses correctly. And even when they go through the feasibility study, they put together the budget report, and they get everything set, there's still mistakes that get made. So it's kind of there's a whole art to software development in general. And in research, a feasibility study is often in the form of a proposal. So sometimes, because this is happening earlier on, in fact, this is the first thing you're going to do when someone hands you a set of requirements, hands you something, you're going to put together this proposal. And this is your response back that says, here's my idea, and can you do it? And what you're doing in that first assignment is really a proposal. You're saying, this is the software development model we're going to follow, and this is, what we're going to do, and this is how we're going to approach the problem. You wouldn't normally give all of that information to the customer, So it's not like a formal proposal. Formal proposal normally has how many hours it's going to take, what it's going to cost, when you want to get paid, what are you going to deliver, what's included, the scope of the project, what is it you're going to actually build. That's more of a proposal that you're going to give out to a client. So the assignment is kind of, not really a proposal, but in essence, what you're doing in that assignment is what you should be doing to prepare that proposal, because you need to really think about time and costs and stuff. So why are feasibility studies difficult? Because you'd think it would be pretty easy to put one of these together. Actually, it is pretty difficult. The benefits are usually very hard to quantify. Very hard to tell, somebody, this is what you're going to be able to use the system for, And a lot of people just don't think of all of the different possible benefits in terms of the business exposure, competition, efficiency, or anything like that. And it's also kind of hard to put a measurement on efficiency. So you're going to improve the quality of something. Well, how do you put a number on it? If you were in the software engineering 1 course, you knew that metrics probably don't really make any sense anymore anyway these days. And it's really hard to measure software in terms of qualities. And so the approach is usually ill-defined. In fact, in a lot of cases, they don't do it when I'm asking you to do an assignment number 1. And there is no approach. It's like, okay, we'll build it. And then they figure out after the fact, after they've already accepted the contract, what are we going to do with this thing? And then they kind of figure out from that point forward. And then estimates of resources are needed. Timetable, very rough, which is why I like to cover project management, actually, but I'll leave that topic alone. Because you actually do have to kind of put a timetable together, which is really a project management kind of skill, that says, this is the first activity that we're going to do, this is the second, this is the third. It's going to take us 2 days to do this, 1 day to do this. We need this person to do this, we need this person to do that. Because you don't want to hire a bunch of people all at once and have them sit around and wait for their job to get ready. What you want to do essentially is a project management approach in which the people come on and they start working when they're needed. And you know when they're supposed to show up, so you don't have to pay for people just to sit around and wait. And then, you can have things done simultaneously. And you can have some order to all of the work so that everything is pretty much done and is completed on time. And then we have organizational changes that might also be needed. If you think about the implementation of software for a business environment, rarely are you actually just going to stick a piece of software in and it's going to work with the organization the way it is and nobody has to change their job. Well, we have a brand new piece of software. Someone's got to use it. Someone's got to essentially put the data into it, print the reports out of it. So people's jobs change, the organization changes. Sometimes you have to hire a new manager or you switch people around. And that's actually part of the project implementation when you actually deliver this thing. And if you're delivering it, if you're training the people on how to use it, there might be some organizational change, and we'll see a problem that occurred in real life that is a good example of that today. So therefore, feasibility studies rely heavily on the judgment of experienced people who are often over-enthusiastic. Yeah, software engineers are very enthusiastic. They want to deliver everything cheap. Well, not really cheap. They want to get paid for it. But mistakes are made at the beginning are the most difficult to correct. As we learned in Software Engineering 1, if we start off with a bad plan, we're going to end up with a bad product in the end, and it's not going to work out well anyway. So it's better to kind of fix things up front and get things working properly, basically set off on the right path. So the decision maker's viewpoint, because what who does the feasibility study? That's an interesting question. It can be done by, depending upon the resources, the development team, or as you pointed out, like the business analyst, or business person, or the manager, or somebody who's running the business end of it would probably do the feasibility study. But sometimes they don't have the technical background for it. So normally you see it done by either like the project lead would do it, or he would contract a couple of people in the team who are experts on the particular technology that's being used to say, hey, do a feasibility study, give it to me in a week, let me know, how difficult is this going to be to build, what's the scope, what is it that we're doing here, should we do this project? So anyone actually can do it, depending upon what's needed in terms of the project. So every project's going to be a little different. So a senior member of the organization must decide whether to begin and in here the slide says senior member. So, it's usually someone with a little bit of work experience, hopefully not a junior, not an entry-level person. So whether or not they're going to begin the software project, whether they're going to take it on, and what information is needed in terms of putting together this report, this feasibility study. We need the client, obviously, who's the project for, and that's actually kind of interesting. Sometimes the project is written or created for the wrong client. They say, oh, these people have come to request this project, but they're not the ones who are going to be using the system. Like the client are going to be these bank tellers over here at the branch offices, but it's somebody else over in a different state that's requested it. So actually, sometimes you actually have to ask, who's going to be using the system? Because depending upon who's using the system, you might have a different type of interface to it, different features might be required, different reporting, different security, stuff like that. Is it going to run from an ATM machine? Is it going to run from a computer? Who's going to run this thing? And then the scope or the boundary of the project. And as we've seen with scope creep and some of the other issues that occur, that could actually be kind of a challenging task as well. The benefits, what are the benefits? Can they be quantified? What is the thing supposed to do? In terms of the technical perspective, is there at least one technical way to carry out the project? That would actually kind of seem like a no-brainer. But if someone's coming to you and asking you for something that's technically impossible, that should be like a heads up right there. Don't do it. Don't take that project because it's technically impossible. We don't have the capability right now to fly across the room, or something, or to do something that the project is asking us to do. Resources also. What are the estimates of staff, time, equipment? You might not actually have enough resources for it. If you're a startup, small little consulting company, and they want this thing done in a week, it might cost you more to acquire the resources than it would to actually turn down the project and take something else and do that in the meantime or something. So resources are a consideration, and also alternatives. What are the options if the project is not begun? Can we put it off? Let's say we don't have the resources. Maybe it requires something that we don't have, some language or some skill in a language or something, or a platform that we're not familiar with. We've never worked with this Linux version. Maybe you can put it off for a week or two, or a month or something like that. Maybe the customer can wait. That's something that you would actually have to decide upon, because if you take on the project and it's not feasible, it's never going to be a success. It's only going to cost you money and probably put you into bankruptcy or something, which is a big risk. And so we'll talk about risk later on. A feasibility study is done to eliminate the risk or reduce the risk of the failure. And here comes the risk. Yeah?
We get sliders from the software company perspective or the client?
From the software developer's perspective, the decision maker's viewpoint. And the decision maker is the one who's saying, are we going to make this, are we going to do this project, or we're not going to take it?
Normally these are the factors of the proposal.
These are points that you're putting in the proposal, correct, and it's something that's written up by the software development team, a senior member who decides, the decision maker for the team. One guy on the team is going to make all the decisions, essentially, and usually it's the owner of the company, or it's the senior manager of the team. If it's a huge company, you might have more than one decision maker. You might have an entire, like Group A, Group B, and Group C, and the company can take on multiple projects and run them simultaneously. But yeah, the organization of it is going to be different depending upon the environment. So let's talk about risks for a second, because what you want to do is kind of identify the risks in the feasibility study, and then also figure out how to minimize them if possible, which is kind of tricky to a lot of cases. We have technical risks, internal risk, external risk, all sorts of different categories. I'll talk about risks in a lot more detail. In fact, that is an entire lecture on its own. You can actually really get into a lot of different categories. So in terms of technical, there must be an outline plan with a rough timetable and staff allocation or allotment. That's where project management helps you out. And usually the software development team has a person who wears a project management hat at the same time. And that person is doing your estimates on your time, your allocation of your resources. Because here's what happens when you take on this proposal and you actually put it together. Customer's going to want to know when you're going to deliver this thing. how long is it going to take you, and what day are you going to deliver it on, and how much is it going to cost. And once you set your price and your delivery date, you're set. That's your contract. So you want to be as close to possible, close to reality as possible, otherwise you're going to end up with problems. So the plan must have a very large margin for contingencies as well, because everybody knows nothing is on time and nothing is within budget, and there's always contingencies to actually think about. So you have to put together a backup plan. So you have plan A, plan B, plan C. So hopefully you don't go to all those different plans, otherwise the customer's never going to come to you again, because if you went to plan A, B, C, and you're on plan Z, by the time the software's delivered, you're going to go, oh, you know what, we're going to go to somebody else who's a little bit more professional next time, who actually knows what they're doing. So, yeah, but you still want to think about contingencies. Projects typically require twice the staff and or time envisioned by the feasibility plan. So you have to pad the hours is what I'm saying, because nothing actually ever works out in the perfect world. Even in the perfect world, it never is on time, never within budget. In terms of external factors to think about, every system interacts with other users, and are the others committed to the necessary efforts? Are the people actually going to learn how to use the system? Is the system going to interface with other systems that it needs to interface with? Are you going to get support or help from all the external factors that are going to be in there? And what are the external pressures and obstacles? That's another good consideration to actually think about. Because you're not putting together a feasibility study, I could have asked you for a feasibility report on that first assignment, but I didn't, because you're going to do one later on in the course for another assignment. But this is part of some of the thinking that you're doing for that first assignment leads into these decisions. So if you think about it in sort of like a method, use a methodology in your brain, in your thinking about how you're putting everything together, you formulate the answers to all of these questions, actually. You get all of the information, hopefully, that you're going to need. All right, so let's look at a case study. This is example number 1, the U.S. government agency. Decision was made before a feasibility study was performed. This is a true-life case that existed, that actually happened, which cost the government actually a lot of money. They decided they were going to build something, and they totally did not even do a feasibility report at all. They skipped the phase completely. And here's a short little description of the outline of the description. And in order for you to understand the example, I sort of have to read this to you, or you have to read it to yourself to kind of get a feel for it. So a U.S. government agency which manages huge numbers of documents and other records. Very slow in moving from paper-based approach to managing digital documents. So they're trying to put together a digital document type of system. You can think of this actually as an example that would apply towards any type of system that you can envision to go from a manual to a digital kind of way of working through stuff. And in terms of the chronological order, in terms of how the events transpired that led to the failure, so Scientific Computing Center of the University of California was commissioned to develop a prototype system to demonstrate the technology. But keep in mind, no feasibility study was done, no requirements were put together, no plan, no development methodology, nothing was done in terms of the pre-thinking. Funds were approved, actually, because they said, the government agency that was going to contract this out said, okay, you guys want to do it? Okay, good, you can do it, here's your money. So they were procured. They procured a major computer system to use for these people. And the National Academy of Sciences was commissioned to report on the technical approach to be followed. So another organization, completely different organization, was commissioned to do the approach that was going to be followed as a result of the prototype. The prototype was the feasibility study, theoretically, but it really wasn't a formal feasibility study. In fact, it was more along the lines of someone putting together a report. And a little note on the bottom, the decision to go ahead was made and the budget approved before the feasibility study actually began, because the prototype took them a while actually to put together. It took them several years actually to put that prototype together. So the National Academy report. So we got this National Academy of Sciences was commissioned to do this report on the technical approach. Obviously it's going to be different than what the other people who are building their prototype are thinking, because we have two conflicting kind of things going on. This is going to happen. and to talk ahead on it a little bit. So the National Academy report, the study finds that the computer system is technically feasible. So they say, oh, okay, this is feasible. And the prototype is promising, but it's incomplete. Prototype never actually finished. And believe it, the prototype is the feasibility study because they skipped the feasibility study completely. They decided, oh, let's just build a prototype. Believe it or not, a lot of software companies actually do this. They do it with websites all the time. They do it with product development. Before they even know what it is they're building, they just start building it. So it's kind of like skipping, not using formal software engineering approaches. So agency needs stronger technical staff because they're doing the people end of it. They're doing the structural changes, the management changes, the use of the system, which they don't even know what it is, really, because it's incomplete at this point. The study was not asked to commit on any external factors, but discovered major weaknesses in the agency's management structure and organizational skills. They didn't actually have the people on staff to actually, who would actually even be working with the system if the system were actually built. Because, you're talking about taking a manual approach to document processing and digitizing it and making it all electronically available. So, it's going to involve business tasks. It's going to involve agencies changing the way that they're processing the documents. So, they never involved any of those people, never got any of that actually reported upon. And so in terms of the National Academy, the technical recommendations that they came up with, the study recommended a phased approach. So this is sort of, if this had been done in the beginning of the study, before they had decided they were going to take on, before the project had actually started, if they had decided that they were going to do something, formalize it, put in an approach, this is kind of like what you're doing for assignment number 1, if you think about it. You're sort of going through and you're saying, well, how should we do this particular project? Well, they recommended, these are the people that are actually, the business people that are actually recommending how we're going to implement it. So the system architecture would maybe create an iterative refinement approach and use phases. So we can, and if you're familiar with iterative refinement, I talked about in Software Engineering 1, you go through, you create a prototype. The prototype gets put into use, it gets changed, and it evolves iteratively through different changes. So you have software release number 1, software release number 2, software 3, until you finally get the final release out of this. But you have something in place, something that's actually running and something that's being used. And they decided, well, they wanted to follow a sequential implementation. So they're going to do it in a sequence. They're going to start, define some phases, and they're going to put together a start, and they're going to implement it this way. And this is kind of like what you're doing for that first assignment. When I said, describe the software development methodology that you're going to use. So it doesn't have to be a model that you find on the internet or that I talked about in Software Engineering 1. It can be a unique approach that you as a software developer decided that for this particular system, this is the approach that I want to take. I want to do it this way. So you can make actually a combination of different techniques and put it all into one if you wanted to. And that decision actually is highly dependent upon the feasibility study, believe it or not. Because you actually have to know what you're delivering, to start out with, how you're going to deliver it, and can you deliver it that way? Not everything can be done that way. Not every project can be done like this. In fact, this one really can't be done this way either. Which is, to kind of bump ahead a little bit, put this in perspective for you. What ended up happening was the plan to build this thing was counterproductive with the nature of the prototype that was being built. And technically impossible for it to be built iteratively, essentially, because it had to change business processes, had to actually involve people that had no idea what was going on, because they never did a feasibility study to figure out that they needed to identify who's going to be using the change document system and to train those people, and all of the external factors that were not considered, which basically caused a lot of confusion. And anyone knows there's going to be confusion. You're never going to get the thing implemented. It's never actually going to work anyway. So, but anyway, let me get you to that point because I sort of talked ahead on that a little bit. So the prototype and the phase development. So we got 2 different teams that are doing this. the prototype is not released to the users except for experimentally. But in the phase development, each phase is released into full production. So we got one team working on the University of California working on the prototype. We got the other national conference team, whatever, working on the development of it. And so we have the developers and we have the users. We have the UC prototype on the top. We have build 1, build 2, build 3, because they're doing it incrementally, using an incremental model. The users, we have the first one, the prototype, is for demonstration purposes only. The second one is phase 1 of the production, phase 2. So they're essentially building the system not really off of the prototype. The prototype was just a demonstration. So it kind of violates, it's hard to tell from this, but the point I'm trying to make is it kind of violates the concept of actually even creating a prototype. And if the prototype is the feasibility study, then you're really not using any of that information. It's like the right hand's not talking to the left hand. They're not working together in terms of building the same system. So let's see what happened. Obvious problems here. So this might make the example a little bit clearer for you. From an organizational perspective, the agency, the senior management, clearly is not ready to lead a very large project that will completely change the agency because they're not thinking about the agency. They had no thought at all about the agency. All they were thinking about was building a prototype and then figuring out how you're going to develop it in phases. And neither one of those two things actually even matched. So they're not even thinking about the users or how the agency policies, how the documents are going to be processed differently. No thought was given to the workflow, the job changes that will affect almost every member of the staff. Okay, so example, imagine the DMV. Hopefully you guys have all maybe you've been to the DMV, I don't know. What if you were to change the document processing of the DMV? What would the staff people do? Actually, that's a good question right now. What do? They just, all right, so if you're not familiar with the DMV, you should be, maybe, I don't know. You get driver's licenses, permits, ID cards for the U.S., you go to the DMV. And it takes forever. It's an age-old problem. And you mention the DMV, everyone will just say, what? You went to the DMV? Oh, no, I'm so sorry. It was a whole day event. You stood in line. Because the processing of those documents is really slow. If you were to take all their computer systems out and give them new systems, it would be even slower. Because they wouldn't even know what they were going to be doing, essentially. Which is kind of, from an organizational perspective, a really bad idea, actually. Preparation. So no preliminary study was made on the volumes or the kinds of data. So the prototype was built to see if we can convert the data, but nobody actually considered what kind of data to look at, nor the complexity or the complex access policies, who was going to have access to the data, what kind of data was going to be there, and then the complexity itself. Major changes to the requirements and design are inevitable once the system goes into production and actually has real users to test with it. So here, we didn't actually go into production. We went into production iteratively, and we had users use it, but it didn't match the demonstration-only prototype, and we didn't take into consideration the complexity of any feedback that was going on between the users using the system, the people implementing the system, and actually incorporating any changes that may have needed to be done, pointing out why essentially obvious problems in terms of, without following a feasibility study, we end up looking at this slide here that says dilemma. And this is where you figure out you're going to file bankruptcy or you're going to, I don't know, take the money and run to another country or something. I don't know, because you can't finish this project. It's not going to work. So the agency doesn't want to return the money to the Congress. No, they're not going to. No one's going to ever want to return the money to the client. The National Academy study was paid for by the agency and restricted to technical considerations, not feasibility. The National Academy, they were in charge of, they weren't the ones building the prototype. The university was building the prototype. They were just doing the technical considerations. Because that's what I mean. Left hand wasn't talking to the right hand. They had two people they hired out to do stuff that didn't coordinate anything. They didn't even work together on anything. The fundamental problem lies at the senior management level. Who decided to do this? Somebody in the government decided that they were going to do this. They got the funds for it. How they got the funds for it, I don't know. The phased approach over many years might possibly work, but only after the organizational problems are addressed. Otherwise, you're going phase by phase. It's kind of like an endless loop. Yeah, iterative development's great, but if you're not addressing any of these problems, you don't actually have a plan, you're just spinning your wheels for a very long time. So the agency has adopted a pure waterfall model and put out a request for proposal for the requirements. Well, that's a good start, actually. So after many years, actually taken about 5 or 6 years to get to this point, when they decided they needed to actually do something more phased. So they implemented, went to a waterfall model, actually. They switched from a spiral model because it was spinning their wheels forever. Nothing was actually getting produced. I mean, work was happening, but nothing was actually forming. So now that they ended up putting a request for proposals, so now they're starting over again, essentially, with requirements, developing requirements. They still haven't done a feasibility study yet, either. How do they even know the scope of this system and what kind of requirements they need to actually acquire? So the little blue text at the bottom, this is a disaster in the making. Yeah, it ended after about 5 or 6 years or so, but yeah, no, it never went anywhere. So let's say we wanted to do a feasibility study. Let's say we scratched all that stuff and said, well, okay, instead of just doing the project, because what ends up happening is people in software, they just want to make the software. You know, let's just put it together a prototype. Let's just do it now. Okay, if you scratch all that and actually take a formal plan and say, okay, let's put together a feasibility study. It all starts with the scope. I mean, it's got to start. You've got to define what it is you're building before you can actually think about what it is you're going to build. So the scope expresses the boundary of the system. So normally, if you go back, I'm not going to flip back because I can't remember what slide it was, but I had scope and I had a bunch of stuff listed out there on a slide. Scope being one of them. Nice starting point, actually. So it will include, and you list the included functions. It will exclude. So what is it going to do? What is it not going to do? What does it depend on? What does it replace? Which is not a bad idea. In fact, when you put together your requirements, you're sort of thinking about this. And this is what we talked about in Software Engineering 1. We started thinking, you know, we're going to put together a requirement specification. We have to think about the scope. And all you did was write a sentence that said, this first version of the Acme document processing system is going to process documents. Okay, good. Not good enough for a feasibility study, actually, because, you know, what does it mean to process documents? What kind of documents, you know, and what kind of security, what kind of other features is it going to actually have? And there's confusion over scope is the common reason for clients to be dissatisfied with the system, especially when they think that you're building something that you're not building. And then, obviously, right there is the starting point for confusion for the rest of the particular project. And is that all you plan to do? But I assume that you were going to do X, Y, and Z as well. And I can't use the system without A, B, C, you know. It's like a really bad starting point, essentially. So in our second example, we have the Library of Congress. Let's say they're going to put together, and they're going to use, in the Library of Congress, put together a feasibility plan. This is how a feasibility plan, in the second example, can go wrong. Actually, just because you do a feasibility study doesn't necessarily mean you come out with the right answer. You're hoping to come out with the right answer, and the right answer is going to be build it, don't build it, or think again. So you're hopefully going to minimize the risk a little bit by doing this, but you're not necessarily going to eliminate the risk 100%, my point. So there might be confusion over the scope, and this is what happened in this particular study. So in this particular example, Library of Congress required a repository system to store and make accessible very large amounts of highly varied material over long periods of time. Okay, that's a long sentence. Outside organization, the CNRI came through to build the repository system. See, these are the software developers. They're going to build the system for the Library of Congress, and they're going to store and manipulate the complex digital objects, hopefully. And nobody built the subsystem needed to organize, validate, and to load the material into the repository. So they're just building a system to store it. There is no system to put the information into it. Right there from day number 1, right there in the beginning, at the number 1 point on the list of items to put in your feasibility, the scope is wrong. It's confusing. The scope said, oh, we're going to build it. this Acme version number 1 is going to be a document processing system. But you didn't say you were going to actually build an input, an output, processing, organization. What are the features going to exist? What features are going to exist? So nobody really thought about that. Library of Congress expected the repository system to include this particular subsystem. And, in fact, they probably went back and said, it's not a subsystem, it's part of the system. This is the system. This is what we asked you to build. This is what generally happens when you build the wrong thing and the customer comes back and says, wait a minute, nope, you said you were going to do this. And you're like, when did I say I was going to do that? Because they heard something different. Anyway, so they considered it an external to the repository system. It really wasn't part of the system they thought they were building. In fact, there's also a common assumption that the system, this particular subsystem, may have also already existed. All they asked for was something to organize the documents. They didn't ask for the documents to be entered into the system. And so a good feasibility study would have seen this confusion, hopefully, maybe. So believe it or not, and some of you are like looking at her, no, I'm never going to do that. This happens all the time, actually. Every time you deliver something and the customer doesn't like it, usually it's because the scope is wrong. They thought you were going to include this, this, and this, and this, and you only gave them this. A, B, and C versus X, Y, and Z or whatever, It happens all the time. So one of the benefits, why is this project proposed? Can you qualify the benefits? So the scope is number 1, benefits is number 2. Actually, I'll keep an eye on here. Slide number 13. Let's see, I'm on number 14. Hold on one second. I want to go back to that other slide. 14 is where I started. That's the slide I'm thinking about. That's the one I keep referring to. What I'm doing now is going through the order in which the decision maker's viewpoint contributes to the final proposal that is created from the feasibility study that we're thinking about. Number 1 was the client. Number 2 is the scopes. And we go into the benefit, and then we go into the technical, the resources, and the alternatives that might exist. So in terms of, and what I've got here are examples, if you haven't noticed, of each one of these points. So let me go back to 14. There we go. Here we are, benefits. So another obstacle, believe it or not, in a feasibility part. As an example, create a marketable product. Great. When you think about products on the market, they have a benefit for particular purposes. Not every product benefits every person. Same way as a XYZ company comes to you and says, I need you to build this system. You might see a benefit to them that's different than the benefit that they're asking you to build the system for. It might not necessarily be to automate the system, going back to the one of the other examples I gave you with the document processing. Okay, maybe the benefit is now everything's electronic and digitized, but maybe they wanted to have a higher level of security on the documents, or maybe they wanted it cataloged differently, or accessible via the web or something, or maybe there was some other benefit that they never communicated to you. So benefits are kind of tricky because there's a ton of benefits, but which one which one do they care about? Is the one you're going to get paid for versus the one that's going to come back and say, hey, you didn't give us what we wanted. Sure, it does this and it does this and it does this, but it doesn't do that. That's what we wanted it for. Then all of a sudden you got a failed project. So let's say, for example, a marketable product might create something that's sellable, maybe improve efficiency for an organization if they care about that. Maybe it's accuracy that they care about. They don't care about efficiency, they care about accuracy. Maybe controlling a system that is too complicated to control manually. Now it's actually, when I think about that digital processing stuff, I think, it's easier to organize things digitally, documents, if they're in a computer, than they are manually. It's probably easier to organize that stuff, but that might be an improved benefit. Maybe a new and improved service, faster response to customers, safety, security. There's all sorts of different benefits. So it's probably not a bad idea to actually identify the correct benefit, the one that might be applicable. So benefits of the National Science and Digital Library System. In terms of the concept, they wanted to create a comprehensive digital library for all of the aspects of the science education, where science and education are both defined very broadly. That might be a really hard one. So the The National Science Foundation studied potential benefits for 5 years before going ahead. It took 5 years to kind of look at the benefits. This is basically what you're looking at is a confusion when it comes to the benefits. So a problem that could occur. So it came to the conclusion that even though the benefits could be qualified, the potential was sufficient to justify a major it was not sufficient. No, the potential was sufficient to justify a major program. So even though they couldn't be quantified, they decided that it was okay to go ahead with it in terms of the feasibility on it when they looked at the benefits. And here's kind of a timetable of what happens. And 5 years from concept to decision to definitely go ahead. So it took 5 years looking at the benefits, essentially. It's kind of a waste of time if you think about it. You could get stuck dwelling on benefits. It's kind of like how we decide to buy something. We have to justify it somehow, and then we just have to decide if we're going to do it or not to do it. Because people dwell on stuff. Like, let's say you want to buy a new computer, and you're thinking, should I go Mac or should I go IBM? No, I've never had a Mac before or something. Or, and then you start weighing pros and cons, and you start listing out all the potential values here, all the potential values here. There's people that shop for stuff for years before they buy something. Actually, people do this with houses too. Should we buy a house this year? I don't know. Should we do it next year? I don't know. You get stuck in an endless spiral of decision making. You start looking. This is essentially what this example is basically demonstrating. It's the fact that they couldn't quantify it. They couldn't put a number on it. And if you can't put a number on it, you can't quantify something or qualify it, you can't decide on it. It has no value that's determinable. But they went ahead with it because it had some value. So they thought it was worthwhile to spend the effort to think about it, to experiment with it. So anyway, I'm not going to go through all of the different things, but we're looking at a timeline of about 5 years, and it took them about that long to say, let's go ahead with it. So point being, you could spend a lot of time on the benefit and not actually see the correct one, not be able to quantify it. And so if you're trying to communicate that, you're trying to work with a customer, explain the benefit, your benefits definitely may not necessarily be their benefit and vice versa. So, okay, technical. Technical feasibility study, is it technically possible? Is the technology what the customer thinks the technology should be? And we all know technology varies year to year. And technology today is not necessarily technology that's current when you deliver the products. So and vice versa. Technology today might actually exist yet for whatever they want 5 years. Feasibility study needs to demonstrate that the proposed system is technically feasible. So that you'd think would be a no-brainer as well. But you get over-enthusiastic software engineers who think, oh yeah, let's build it, and it's going to use infrared, and it's going to be a remote control for a TV that I can press right here, and it's going to work at home. And it's technically impossible for a line of sight to exist between here and home. It just doesn't work that way. But they go ahead with the project, and they sign on the dotted line, and they take the down payment from the customer, but they can never return. They can never deliver the system. So a rough outline of the requirements would determine that. Would say, well, it's required if I press the remote here for it to work 25 miles away or whatever. Okay. We're going to have to use something else, a cellular or something. And a possible system design. That would also include the database and also the distributed system design. Because sometimes they want components on this network to work with components on this network that can't communicate through an architectural difference, lack of middleware, lack of technology. It hasn't been until maybe the last 8 to 10 years that distributed computing, and remote objects was actually feasible. So, if you think about the concept, it might actually be a barrier to getting it done. Estimates on the number of users, the data, the transactions. Number of users is kind of interesting. We all think, build a system and then, 10,000 users. System doesn't work. System crashes or something. And there's AT&T right there. Build a network, and then all of a sudden, too many users. Bad quality of service. No connection anymore. And then everyone leaves because the network's bad, which is nice because those people who stay are going to get better network service pretty soon if you have AT&T. All right, so possible choices of software to be acquired or developed. Actually, sometimes the choice of the language may also be a technical consideration. They want something done, they want it done in a particular language. It may not necessarily be possible. The library support for whatever modules, for whatever driver information that you might need to include may not be there, might not exist. So these are very rough numbers, and they're fed into a provisional plan. It's used to estimate the staffing, the timetable, the equipment. These are the numbers that come out of the feasibility report that go into the project plan, actually. So these are important numbers, actually. But if you think about it, nothing's started yet. You're predicting, you're estimating ahead of time what you think, and you base it on experience. So what if you're a brand new software development company, you don't have any experience? And how many projects do you build are identical to the last project you built? Not too often either. So everything's brand new normally, which causes problems. So the technical approach actually followed may be very different from the approach that's actually done in the technical feasibility study. Which is actually kind of an interesting note as well, because what managers and business people, going back to his comment, who puts together this stuff? Senior management. All right, so the guy who's actually doing it, the lower end, hands-on tech, he might have a better idea, actually. In fact, hopefully, I would hope that he would have more background in the technical stuff, which is why the senior management actually has to come back and consult with the lower level people. And I shouldn't call them lower level, the different skilled people, the people with the technical background who are doing the implementation work versus the management level work that might actually have some valuable input to use on this. Okay, we also have to think about resources and planning, which is why software developers usually have to wear a project management hat, actually, because they have to be able to put together a plan. The feasibility study should include an outline plan. This is the plan you're doing for assignment number 1, actually. It's not a real plan, like a project plan, but it's an implementation plan. So you're looking at a spec on a system, and you're saying, if I had my choice to implement this in the best way possible, how would I do it, essentially? Would I use a waterfall model? Would I use an iterative approach? Would I use prototyping technique, an evolutionary prototype? You have some choices. You can actually estimate out the staffing as well, and the equipment needs and the preliminary timetable. You can actually do that for your project because you have to actually say what's going to happen in each one of your phases. After you mapped it all out, you actually could probably determine how many days with how many people it might take you to actually put together the particular project. And then you can figure out how much it's going to cost you, hopefully. And not this lecture, but one coming up, I have one on costing, estimating. So figure out if I were to put a price on what it would cost me to develop this particular project, put a price on it. Given a dollar amount that someone makes per hour, given how many hours that person has to work, how much is it going to cost you? It's not, estimating out software projects is different than hardware. Hardware's got fixed prices, You go, this board costs $2, so this component costs $3, and then you add up all the pieces and that's how much the board costs. But how much does it cost to build software? A little different. You got troubleshooting, debugging, fixing, time to build it. All right, so you can also identify major decision points, milestones you could put together. At this particular point, we're going to decide to continue, or we're going to decide to stop. Because that's, and I talked about this in Software Engineering 1, the graceful decision to stop a project, when to cancel, could actually be part of your project plan, because when all else fails, you can always just throw in the towel and walk away from it. Because a lot of cases, you could buy yourself a nice brand new car with the rest of the money rather than dumping it into something that you're just going to throw away and not get any benefit out of completely, because it's just going to not end correctly anyway. You might as well just minimize your losses and walk away from it. And then you'll just never have any business with that customer again, because they're never going to hire you to do anything after you failed. But there's other people. So anyway, so you can imagine what kind of decision points you could possibly put into the plan. Identifying interactions with and dependencies on external systems. Not a bad consideration for the feasibility, technical resources and planning, because you actually have to work with other systems. I can't imagine any software system these days working on an island of its own. In fact, everything's networked. You know, if it's not the internet, it's a private network. It's some system it has to work with, some database, some other system. So external systems are very important to consider, actually. And provide a preliminary list of deliverables and the delivery dates. How are you going to get paid if you don't have delivery dates? Usually people just guess. You know, oh, 2 months, 3 months. Well, that should be enough time, right? You know, to get something done. It's kind of like how you kind of estimate how long it's going to take you to do an assignment. Oh, an hour, 2 hours. Does it ever really take an hour? When I do something, it takes twice as long normally than I imagine. And then the last part of the feasibility study report is to actually come out with some alternatives and actually look at the risks. Because after the feasibility, then we start looking at risk analysis. Because just because something is feasible, we can actually do it, and we have it spec'd out correctly, we may not necessarily like the risks that are associated with it. It might be something that, you know, has a high risk of failure. Maybe the customer is brand new in the business that they're doing, and they might actually fail before you complete your project, and you're never going to get paid because it wasn't your fault, it was their fault or something. There might also be other situations, you know, economic events, holidays, something that might happen that might interfere with your best plan that goes on that you can actually account for. So in terms of the alternatives, the feasibility study should identify alternatives, and it should also list out the risks. And these are identifiable risks at the beginning of the project. What happens during the project is a completely different story. And the alternatives that happen during the project are completely different. Because if you're working on a software development project that takes a year, year and a half, 2 years, a lot of stuff can happen. Your main senior programmer can leave the country. You know, your idea might be obsolete. A lot of different things might happen during the course of it that might change, and those are actually part of the risk assessment plan that constantly monitors risks and reevaluates the situation to come up with alternatives that might exist in case something else happens. So in terms of the alternatives, you can identify, you can continue with the current system, enhance it, or create a new one in terms of alternative choices or plan Bs that you might have as the software continues. You could develop in-house or contract out, and how will a contract be managed if you're contracting it out, subcontracting? This happens when, as an alternative, you've got it all planned out, but you're behind schedule. So you decide, well, let's get some contractors. Let's go find some ITU students to go help us finish this project, which is how most of you get jobs, actually, because companies around here are always looking for people to fill in, to help out, to essentially take over because they don't have enough people and it's running behind schedule and they can't figure out how to do something. So they get contractors to come in, solve problems quickly, and then you're done. Then you move on to the next contract and to the next contract. You know, who's going to manage that? How's it going to work? You can actually put that in the feasibility plan. You know, if, for example, we're 2 months behind schedule, if we've hit that date, maybe 3 months. Let's call it 3 months behind schedule. Then we go call up ITU and get some consultants, get some contract programmers in here to fix our problem or something like that. So. All right, and in terms of the risks themselves and how you're going to identify that in the feasibility report, you know, at a minimum, you might want to list what might go wrong, you know. Let's say you're building a stock market program, the stock market crashes or something, I don't know, you know, or the housing market falls down and, you know, your particular project is not going to work, it's going to be a failure. And how will the problems be identified? How are you going to look for them? When are you going to look for them? Are you going to look for them? How are you going to know it? And what are the fallback options if something happens? So that's another consideration as well. So techniques for feasibility studies. These are basically, you know, ways of going about the process of developing a feasibility study. And it really is a study. Now I keep saying feasibility report that turns into the project proposal. So there's a study that goes on, and the study actually has different phases to it. It can be done much differently depending upon who's involved with it. As an example, you can give clients an appreciation of the system if you involve them early on, and then they know that you're building it for them. Anyone who is actually thinking that you're taking in consideration of what they're saying. So let's say you're building a bank teller system, and you go out to the bank and you talk to the clients. You say, hey, we're going to build this new system for you. And what kind of features do you want? Not only can you find out what it is they want in the system, but all of a sudden they feel like, it's for them, that they're getting something, higher level of appreciation. That way when the system actually gets installed, they're not pushing it back and going, hey, what is this? How come we have this new system? Where did this come from? Instead, what they're doing is they're taking it and going, oh yeah, look at this. Look at this. It's here. It's our brand new system. You can do demonstrations, mock-ups, walkthroughs. So you're training them on how to use the system. You're getting them involved in the development process. They have a higher level of appreciation for the system. You can outline the budget, hopefully, in terms of the study by different scenarios and say, well, if we have 5 people and they're working 5 days, or what about if we have, 10 people and they're working 2.5 days? Double people, lower the days. You can work out the different scenarios. This is how much it's going to cost us. Or if we use this equipment in this building, then this is what it's going to cost us. If we have everybody work from home, we have to buy them a computer. If we have rent an office space, we can have them all come in and share a computer. So we can work out different scenarios in terms of the budget and outline everything. And I may also look at the phases and the milestones and deliveries of approximate dates, and then adjust the dates and say, well, is this realistic? Show it to somebody else and say, is that realistic? So the study actually is the planning. It's not like writing stuff down on a piece of paper. There's a lot of behind the scenes kind of thinking that goes into the study theoretically. So when I say theoretically with a smile, because not always does that happen. Some people just put together these feasibility reports, just type it all. Oh, here it is. It did 2 weeks. Where did you come up with that? I don't know. Guessed. They just kind of guess at stuff. And is it better to guess than not guess at all? I don't know. There's a fine line between how valuable the feasibility report actually turns out to be, how valid it is, whether it's even making any sense. So there's the report. And here's the report that I started talking ahead on. This is that written document. It's usually a letterhead on the top. It's a fancy little report somebody types up after hopefully they've done the study, after hopefully they've actually have some reasoning for some of the decisions they're putting in here. There's a general audience to it. It's the client, the financial agreement, the technical manager, management staff, CEO, people who are paying for this project. Actually, what you can do is put together a feasibility report along with a business plan, take it over to a bank and say, hey, look, I need a loan. I need to borrow money for this project. They're going to ask for a feasibility report. Who's going to loan you money to build something you don't even know if it's technically possible or physically possible or even if it's a good business idea? That's what a business plan is all about, actually. So a feasibility report to a software engineering company is the equivalent to a business plan to a business company. Every company is a business company. So it's kind of like it holds about the same amount of weight is what I'm saying. So short enough that everybody reads it, hopefully, not too technical, written for business people, long enough that no important topics are skipped, hopefully. I've seen some feasibility reports that are like 2 inches thick, and you're like, oh my, I can't read this. Nobody reads it. And it's kind of like a business plan, Are you really going to read the whole thing if it's too big, if it takes you like months to read the thing? Or is it something you can actually look over in a couple of hours and get a feel for what the idea is? Details are often included in supporting documents. Hopefully you have facts and numbers and references. How did you come up with this? How did you come up with that? And a lot of feasibility reports are based upon previous projects, actually. Because what you can do is you can come back and say, well, in the last project where we built this document processing system, it took us 12 years and $2 million. Okay, so this time it's going to take us 13 years and $4 million because the cost of labor has gone up and, you have a more complicated system or something, So, and then if someone came into me and said, 14 years? What? Why are you thinking it's going to take that long? That might actually be a realistic number. So hopefully it won't be in a project that takes you 14 years because that's going to be obsolete by the time it's even built. So. All right, so it should be well written and well presented. It should be like it's a business plan. I mean, it should be a formal document that's not written on the back of a bar napkin or something. It should be like, printed up correctly. So, how to minimize risks, and several different targets and different levels of functionality. What you can actually do is kind of prioritize the functionality. You could do this in the feasibility report. You can say, this is what the system is required to do. And you can get a sign-off from the customer that says, we're going to do all of the required components absolutely guaranteed. And then we have the desirable, and then we have the optional phases that come after that. So you can say, well, if our plan goes as we expected, then we're gonna deliver you these required features regardless. But if we are early, we'll give you this desirable one as well. Or we can kind of phase out on a separate plan, like the next upgrade to this is going to have these desirable ones. Or you could phase it out and say version 1, version 2, version 3 of the system, and then kind of like strategize it out. If you do that, then they're not asking for the world and only getting the required features. Because you're probably only going to realistically give them the required features in the first version, because you're going to have to work out the kinks in the development process and actually make the thing work. And using a visible software process also is good, because then you can document it, and which is kind of the theme for that first assignment, going back to that again. That's visible. When you can say, I'm going to use a waterfall model, or I'm going to use a spiral model, and these are the phases, and this is what's going to happen in each one of these phases, and this is what is going to be delivered to the next one. And don't actually assume that a waterfall model is going to work for it, actually. You might actually have better ideas than that, hopefully. Basically, then you have the deliverables that you can specify out as well, and how much time is it going to take you for each one of these phases and things of that nature. When you make it visible, then you make it something that can be communicated as well. You make it something that can be exposed. It's not a mystery anymore, hopefully, and it's something that can be shared among the team. So good communication within the team, and with teaching assistant. I don't know why that's there. I think that's a typo, actually. You don't want to communicate all your projects with the teaching assistant. She might actually get overwhelmed about one. So, I left this in here because it was based on a project, actually, for an assignment that I took out of the course, actually. So, don't have to worry about the teaching assistant for that particular deliverable. It's a good thing I was reading it, I guess. All right, so this came from Software Engineering 1. This last slide here, where it says, "Good processes lead to good software. Good processes reduce risk." Yeah. Actually, if you've taken Software Engineering 1, you've read that before, probably multiple times. It's not a bad thing to actually remember, because it proves to be true, actually. So, all right, so the feasibility report is a topic for a future lecture. And looking at the specific requirements for the feasibility report is what we're going to kind of talk about. Probably not the next one, but the next, probably about 2 more lectures down the road, because I want to talk about costing and estimating as well. But not today. So if you outline a plan, and this is kind of the summary in terms of the report contents and concepts in general, outlining a plan showing the principal activities, the milestones, the deliverables, discussing it, using it as for business considerations, using it as a form of communication, doing some risk analysis, using the feasibility report to do your risk analysis is not a bad starting point. Figuring out what can go wrong, do you have a backup plan if things do go wrong? Because nothing ever goes as planned normally. So that is everything you ever wanted to know about feasibility reports. And if you came in late, I've been talking about assignment number 1. This particular lecture, number 5, will help you kind of think about what I'm looking for in terms of the deliverable. You don't have to put together a feasibility report. You don't have to put together a risk analysis report either. You'll be doing both of those in future assignments. What you're doing for the first assignment is the first part of it, and it's more of the study component. It's looking at a set of requirements and deciding what methodology would I run with this. What would I use? How would I do it? What's going to end up happening is you're going to read the description and you're going to get overwhelmed, because there's a lot to it. You're going to wonder, and you're going to get confused, and you're going to say, well, this model doesn't work. And this model doesn't. I will tell you right now, no one model is going to work for that. It's a little bit more complicated than that. You actually kind of have to think of outside of the box, think about this model, think about that model, and put it all together in a unique configuration. Tell me what you're going to do in each one of the phases. It's not a formal report again. You don't have to like make it look good. You can type it out, put it in a Word document, 2 to 4 pages long, any format that you want. You don't have to reference any material. However, if you do find an obscure software development model that I've never heard of, or you think I may not have ever heard of, it's not a bad idea to maybe put a link where you found it. If you actually, like find something that you want to use like that, which I don't think you're going to actually be able to do. So, questions. We're actually going to get out early today. So we're done. We're done unless anyone has any questions. All right, that's everything you ever want to know about, about all that stuff.